Hello everyone, welcome back. Today we are diving into two interesting problems from the CSES Dynamic Programming playlist, and the problem name is coin combination 1 and 2. This video might be a bit long, but trust me, it will totally worth it. We will break down each and every step in the simplest way possible. So by the end, you will have a solid grasp of how to approach this problem. So grab your notebooks, stay focused, and let's get started. Okay, let me read the problem statement first. Uh, Consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce money sum x using the available number of coins. Okay, so we are given an example to us. Uh, okay, so let's understand the problem statement. Let me remove this, and yes, so we have to make the sum equal to 9. Okay, using these type of configurations 2, 3 and 5. The order of choosing these subsequences matters in this problem. Okay, like you can see this example. We can choose 2 to 5, 2 5 2 and 5 2 2. Okay, so the order of choosing matters in this problem, in this version of problem. Okay, so in order to solve this problem, first we have to define the states of dp. Okay, dp of I is equals to, it represents the total number of ways to make the sum equal to I. I think first we have to understand the memoization solution to this problem. So let's understand this. Okay, 2, 3, 5, and we have to make the sum equal to 9. Okay, so we have again two options. First option is to not take. Okay, not take, and second option is to take. Simple. Okay, so my first option is not take. I will skip this element and I will move to the next index. Okay, fine. Now my second option is to take that element. Okay, if I will take this element 2, then my 9 will reduce to 7. Okay, 9 will reduce to 7, and I will increment my answer to 1, my number of ways to 1. Okay, this represents there is one way to selecting this element. Okay, or I can remain at this index. I will not move forward because we can choose two multiple times, not a single time, but we can choose two multiple times. Like if I have to make the sum equal to 8, I can choose 2 4 times to make the sum equal to 8. So that's why we are not moving index plus 1. We are remain at that index. Okay, so let me clarify this again. Not take, we will move index minus 1, v and dt. Okay, then second part is to take. Okay, I will declare with initially. Okay, so let me think, just go through. Okay, this is the memorization code. Okay, so I can take this element only and only if v of index is less than or equal to my target. Okay, v of index is basically 2 and target is 9 in this case. Then I will take is equals to 1 plus get index minus 1 target will reduce to v of index minus 1, v of index, and sorry, this is not index minus 1, this is only an index, and we will return b and d. Okay, after this the final answer is take plus not take. Why take plus not take? Because we have to count the number of ways. Okay, that's why take plus not take. Okay, so I hope this much is clear to everyone. So I will show you my code for better understanding. Okay, this is the code. Answer. Okay, if index is equals to 0, then I will return target modulo v of 0 is equals to 0. Okay, I will try to understand this part. Okay, if my okay, 2, 7, 9 and 8, if my remaining target is 6, okay, then I have if and I'm standing at this index. Okay, if 2 if 6 is divisible by 2, if 6 is divisible by 2, then I will return 0 because I can choose 2 multiple times. This is my base case. Okay, I hope this understands. I will call a function not take, and take is equals to 0. If v of index is less than target, then 1 plus index and target minus v of index, and then I will add the multiple ways. Okay, so this is the memorization code to this problem. Now we will moving forward to tabulation. Okay, so tabulation is the similar way to do, but instead of doing recursively, we use two for loop to do this. Okay, so now dp of I represents the total number of ways to make the sum equal to I, right? Okay, so I will run a loop from I till k. Okay, why I'm running this loop? Because I have to make the sum k at the end. Okay, so uh, I will run a loop this outer side. Okay, so to make the sum equal to I, we have three options, right? We have n options, not three. We have n options. Okay, like if I is 10, then I will and my arrays look like this: 2, 3, 5. Okay, so to make the sum equal to 10, we can use 2, 3, 5. Okay, so my second loop will run from j is equals to 0 till n. Okay, now I will add that condition. If I if I is greater than or equal to v of j, then I can take dp of I is equals to dp of I plus dp of I minus v of j. Yes, that's it, guys. Okay, so what is my final answers? Final answer is stored in dp of k. Okay, so I think the one thing left is only the base case. So base case is very simple, I guess. dp of 0 is equals to 1, because to make the sum equal to 0, we have only one way to not select. Simple. Okay, so I think the first question is clear. I will show you my code. Yes, this dp of 0 is equals to 1. It means we have one way to select to one way to select one way to make the sum equal to 0. I will run a loop from 1 to till k and run a loop from j0 till n, and if v of j is less than or equal to I, then I will add the number of ways and take modulo of that, and yes, I will return dp of k, which is my final answer to this problem. Okay, so I hope the first problem is clear to everyone. Now we are going to move the second version of this problem. Okay, so the second version. Okay, let me erase this. Okay, consider a money system. Basically, the question statement is almost similar, but the difference between them is the number of distinct order ways. Like, okay, so I will open this and this. In this version, we are choosing multiple times, like 225, 252, 522. Okay, we are counting three times this. But in this problem, we are counting only one time, 225. So we have to choose the number of distinct ways. Okay, so let's move to the solution. In order to solve this version of problem, let me just copy this and pasted it here. Okay, so in this problem the states of dp is same as the previous one. So what is our states? Represents the total number of ways to make the sum equal to I, right? So this is our dp of I. Let's understand the memorization part, because it will be much better if we understand memorization first and then go for a tabulation. Okay, so let me just copy the previous one code. uh, yes, this is our memorization part. Yes, okay, so this is our non-take part and this is take part. Let's understand the take part. Okay, 1 plus get of index and target minus v of index and v and dp. Basically, what is 1 represent? 1 represent the number of option to take the ith element. Let me explain this. If my array element is like this, 2 3 5, okay, the option of choosing 2 is basically 1. Okay, again, option of choosing 2 is 1. Again, option of choosing 2, 1. Okay, so we will adding each one of them, but instead of these adding 1, we can only choose we can only have one option. Now basically I want to say that instead of adding this one to our answer, we will return this one in our base case. Instead of adding this, it will give me a number of distinct order pairs. That's it, guys. Okay, nothing will change. I will only move this one to my base case. Yes, uh, let me show you your code. Okay, so this is our memorization code. We will found runtime error because we have to do tabulation as well. Okay, so this is our memorization code. Yes, as you can see, non-take part same, take part same. Instead of 1 plus, we can do we will return 1 here. If my target is 0, then I will return 1. It means that we will found a subset. Okay, this is our base condition. If my array will go out of the bound and my target is less than 0, then I will return 0. Okay, so I hope the tabulation the memorization code is clear to everyone. Now we will be moving to tabulation part. So for tabulation part, we will run two for loops. The first for loop goes from 0 till n, and the second loop will go from k till k. Okay, so basically we will switch the positions. Okay, in the previous problem, this loop will be outer and this loop will be inner. Okay, but in this problem we will switch these positions. Why we are switching this position? We need only one way instead of multiple times. Okay, basically 2 plus 2 plus 5, we need only this way. Okay, not 2 5 2, 2 plus 5 plus 2, or 5 plus 2 plus 2. Basically these three will be combined in this way. Okay, uh, let me explain this again. It will be much better for, okay, to understand. For the previous problem, we will be choosing to make the sum equal to I. We will run a loop from 0 till n. Okay, for the array elements, we will choosing 2 5 7. These are my array elements to make the sum equal to I. Okay, this was my previous problem. But now in this problem my situation is changed. Okay, so I have to count only single path. Okay, to calculating the single path, we will run loop from 0 to n and 1 to k, because now in this loop we will be making the jth element. We will be making basically this is j, this is I. Okay, we will be making jth element by choosing I operations. Okay, I hope this much is clear to everyone. I know it's bit difficult, but yes, that's it. It will be much better if I will show you my code. Okay, so this is the tabulation code of this problem. We will declare the dp k plus 1 0. Dp of 0 is equals to 1, as we discussed in the previous problem. Okay, uh, to make the sum equal to 0, we have only one option, we have only one way. Okay, run a loop from 0 till n and x is equals to 1 till k. If v of index is less than x, then we will add the operations. Okay, yes, that's it guys. Okay, so I will share a link of these two problems in the description box. You can check this out. Okay, so thank you very much guys for watching this video.